Alright, okay, so today, basically, the topic is Internet of Things, right? How many of you that fully understand what is Internet of Things? No? No one? No one? No one at all? Yes? Alright, okay. Maybe some of you are aware what is Internet of Things, but might be shy to raise your hand. Right, never mind. So by the way, my name is Muhammad Khairi. I'm one of the lecturer for School of Technology and Engineering. And when we talk about IoT, it's going to be related with Industrial 4.0. Alright, so for Industrial 4.0, is there any of you have any idea what is IR 4.0? Tak ada juga? Okay, alright, so we going to have long day, right? Right, Neman. Right. So regarding this training will consist of 2 days, right? Today and tomorrow. I hope whoever attend today going to be attending tomorrow as well before you go for your semester break, right? Okay. So when we talk about IR 4.0, our 4.0, when it stated 4, there must be 3, 2, and 1, right? So there must be 3, 2, and 1. Right. So the revolution from 1 to 2, 2 to 3, and 3 to 4 is the technology, right? So, for example, let's say Industry Revolution 1, for example, we still do it manually, right? Okay. Second, maybe half of it automated, right? Then the third one is fully automated, for example. Right, so the biggest question is 4.0, apa dia? If everything already fully automated, why we need to evolve to Industrial Revolution 4? Any guess? No? Right? So, for example, let's say that we have machine, right? So basically there are conveyor and there are a box going to that machine, right? We said here that industrial 3.0, everything is automated. We need less manpower, right? But when we reach to industrial 4.0, this thing must provide data, right? So when it involves data, it also will relate to other element. For example, to send a data, to protect a data, to encrypt a data, to analyze a data, right? So most of IR 4.0 relate to data, right? For example, one of it is Internet of Things. So basically, this what we call as a thing, right? Thing basically items lah, right? Any items, okay? So when this want to send a data, there must be communication, right? The medium, nampak ke? Right? So everything that want to send a data need to have network medium, network protocol, right? So one of the pillar for IR 4.0 is IoT. There will be 9 pillars. 4, 5, 6, 7, 8, 9. One of it is IoT, right? To what? To complement the IR 4.0, right? Other than IoT, apa dia? What else? Denny? Yeah? No. Huh? Smart manufacturing or smart or smart what? Factory, right? Cyber security, if I'm not mistaken, right? Cloud computing. What else? Big data, right? Okay, so there are 9 pillars lah. You can check to our national IR 4.0 agendas, right? So, yeah, so that is why we are here today to cover one of the pillar for IR 4.0, which is Internet of Things. Alright. Okay, so the objective of this training, 80% of it is hands-on, right? So that's why you can see some devices on your table. Unfortunately, you need to share the device, yeah? 2 person, 1 set, right? So the first objective to get participant familiarized with the fundamental concept of IoT as part of IR 4.0 pillars, right? Then objective number 2, provide participant with more hands-on and practical training activities. This training program can serve as a much needed supplement to student courses, right? For those who study here at Peninsula College, you notice that IoT is none of the subject list, right? But it is important for you to deploy on industry. Okay? Betul, Denny? Okay, alright. So that's why we conduct this kind of training, so that bila you apply a job or during your career development, career pathway, when people talk about IoT, at least you have an idea how it works. Okay? Right. Alright. So for day 1, for first hour, 45 minutes left, we should go to IoT itself. What kind of element that can we call IoT? Okay, right? Then start from 10 a.m. up until 5 p.m. All are hands-on, right? Siapa yang dah ambil programming? Introduction to programming. Who already took that subjects? Raise your hand, I want to see. Raise your hand. No. Siapa dapat A? Who got A for programming? Mr. Kelvin, betul kan tak ada A? Alright. Siapa yang dah ambil networking? Introduction to networking. Kenapa semua malu-malu ni? Right. Dean. Terence. Yang lain? Yang lain repeat lah. You want to see me again, is it? Next time? Alright. I believe all of you already took programming, networking, and maybe visual programming. Dah kan? Belum? Visual programming dah? No check. Dah. Danny, done already, right? Okay. Alright. So IoT will make use all of this knowledge, right? So yeah, for the first hour, we will see how we utilize or where we utilize this kind of knowledge, right? Okay. Then on the second day, we start to use our networking skills. We need to communicate between one item to another item, from one thing to our PC, from any devices to any other devices, right? Okay, so we try to send data. Then that data, we will try to log, L-O-G, log, yeah? So we need to keep that data for us to give to our data analyst, for example. Alright? Okay, Internet of Things refer to network of physical objects or things embedded with sensors, software, and connectivity, enabling them to collect and exchange data over Internet. When it's stated here, physical objects, meaning that anything can be a things, right? Not only the most obvious thing like our smartphone and so on, right? For example, uh, this projector can be a things, right? And can be one of the IoT things. How? First of all, it need to have something to measure, right? The temperature maybe, the duration, or the humidity, for example, any kind of parameter, right? Then that parameter need to be sent to the cloud, right? Any other example? Oh, semua mood cuti ke? Camera, yeah. So camera, what we can measure? Temperature maybe, shutter count, humidity as well to avoid fungus. What else? Okay, so yeah. Okay, maybe we will have another example whereby we apply IoT in agriculture, for example, right? We try to apply for smart farming. A single tree can also be a thing for IoT. So basically, a tree, apa yang kita nak measure? What we can measure from a tree? Humidity. Do you know what is humidity? Do you know? No. Alright, okay. Humidity meaning right. So basically we breathe in oxygen, right? Then we might have what we call water lah, right? In our air, right? So humidity is to measure humidity lah kan? Moist in air lah kot. Right? So meaning that in our circle, in our environment, our area, how moist the air, right? For example, let's say that you go to Egypt, for example, the humidity might be low. But for us here, rainforest, the humidity might be higher than Egypt. Something like that. Okay? Boleh? Right. Temperature tahu kan? Temperature is based on Celsius. Right? Then the concept behind IoT is to connect, integrate this object into a network. For example, a tree just now. We try to give the internet to the tree. Right? for the tree to transfer the data, right? By gathering data from sensor, IoT devices can provide real-time information, enable remote control and monitoring, and facilitate automation and decision-making processes, right? So this is what IoT can do. Right, so even inside our house, right, any of electrical or electronic devices can be a thing as well. For example, air conditioner, aircon lah kan. Aircon, for example, let's say that aircon, right? So what can we measure from an aircon? Macam ni kan, aircon. Apa yang kita boleh measure? Temperature. The duration, right? The duration, how long? Huh? Wind speed. Dia punya fan speed lah, right? Lagi? Right. So, let's say that let me try to draw our map. Penang sini. Then okay. Right. For example lah, ini Malaysia. Okay. Every house has one aircon, right? And every aircon feed a data. For example, to Panasonic, for example, right? Then aircon basically macam mana? Kalau something like this, right? Then outside there we have our compressor. Kan? Alright, let's say that over here, the aircon over here, most of it, the temperature might be around 30 to 35 degree. Okay? But in our peninsula, here, the temperature might 35 to 40 degree. Right, so kat sini lah temperature dia. Temperature. Outside temperature. Right, so if Panasonic has this kind of data, to which part that they should sell? Why? 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 Which one? Tadi yang ni? This one? Okay, this one. The reason? Yes, because it's hotter, right? So, there are possibility for them to purchase and use the aircon, right? Kalau dia advertise dekat tempat yang tak berapa panas, rugilah dia, right? The people there might not use aircon at all, or maybe they have it but not using it, right? Or one house is just one aircon and something like that. But if you advertise to somewhere that really need it, you have higher possibility for them to purchase, right? So that's only based on one sensor and one item, right? So in our house, we have a lot of other items, okay? Rice cooker ke, air fryer ke, what else? Microwave, fan, televisions, and all the smart devices, right? Air purifier and so on, right? So all of that items can be connected to the internet and send a data, right? So other than in our house, what else? For example, for automotive, for our cars, right? So currently, I don't think that our car sending data to anywhere. But if our car able to send data, I think our car will send a lot of data, right? Because of what? On business perspective, they can predict when you need to have your maintenance, when you can change your tires, when should you renew your insurance, and so on, right? On our side, we can monitor the health of our car. All right. So, yeah, that is IoT, and this is the major component in IoT, right? So a thing send a data to a gateway, then send a data again to the cloud for analytic and user interface. So this is what we try to do within these two Ds, right? Some of the part might be simplified, but I hope you can cover all of these major components in these 2 days, right? Sekejap Alright, never mind. Alright, okay. So, what kind of knowledge that we need to have for developing IoT or to become an IoT developer, right? One of it, electrical and electronic. Okay, so this is a major part of it. Then we need to know programming. For our case, we will use C++, right? Okay, then visualization, and another one is networking, right? For communication, right? All right. Okay, electrical. We will cover a little knowledge of electrical. So basically, electric travel in two conditions. One is alternating current, and another one is direct current, right? Alright, for example, let's say that our devices, our phone, our PC, our laptop, it operates in AC or DC? AC or DC? DC, eh? Electronics operate in DC, okay? But the socket plug that we have, AC or DC? AC. So, how it changed? Right? So, usually inside our charger, there are transformer that transform AC to DC. Okay? So, that is the difference between AC and DC. On our plug, in Malaysia, we provide 200, roughly 220 volt AC. And our electronic devices can be varies from 12 volt, 24 volt, 5 volt, and so on. Okay, so this is the look of the transformer. Don't worry, we no need to build this kind of thing. I just want you to know that the difference between AC and DC. Okay, DC are essential for powering electronic devices. It serves as the electrical energy source either from batteries, DC power supplies. The DC voltage is supplied to the device power input, regulate the required voltage level, and then distributed to various components within the device. Right? Okay, done. Electric basically in two forms, AC and DC. Right. So, let's say that we take DC, right? we go further. Electric has three value: the voltage, current, and resistance, right? Okay, so basically, for example, like this laptop, it will operate around 19 volts, for example, DC. Okay, so every devices has its own voltage operating power lah. Alright. Okay, current pula apa dia? Current, it is more on loads, right? For example, your phone charger, it will fix 5 volt, right? Some of you maybe use 9 volt, right? But the most common charger using 5 volt, right? But to determine how fast the charger charge your phone is based on the current, right? So that is the difference between voltage and current. Okay. Then the last one, resistance. Resistance ni apa? Resistance where we need to load the power, right? For example, let's say that this power supply provide high current or high voltage. We want to reduce the power. We use resistance, right? So that's why the animation here shows that the ohm will drag the amp from moving forward. Okay? Alright. Alright, so another part of electrical, we have series and parallel. Okay? So when we develop a circuit, we need to know what is the difference between series and parallel. Right? So basically, on the right side is series, whereby the lamp or the LED connected to each other, right? But for the parallel circuit on the left side, it has its own power from the battery. Okay? Alright, so there are pros and cons for both of it. But let's say that we take series circuit. Apa disadvantage dia? Din, what is the disadvantage of series circuit? Yeah, correct. So if one blow off, then the others cannot work, right? But when parallel, if one blow off, other two will remain turned on, right? Okay. But in parallel, the power will be divided into 3. Okay. Meanwhile, series, the power will remain same. Then after the first bulb, it will only reduce the usage of this first and then move to other bulb and so on. Right? So this is the difference between parallel and series. Right? So we will use this knowledge when we develop our circuit. Right. Okay. So far so good? Ada soalan? Kita awal sikit before we go into our items. Right? Alright. Nak take a break first or not break first? Break first. You want a break or you want we just continue? Still early. Is it still early? Continue. Oh, dengar lecturer senyap ni. Alright, okay. Alright, so, okay. So, if you have a look inside the container, that we will have, apa dia? Let me take one lah. Alright, so this what we call as a breadboard. Okay, tengok Dah buka ke? Kalau tak buka, buka. Alright, so yang ni nama dia breadboard. Okay, I don't know, it doesn't look like a bread, but the name is breadboard. Okay, alright, if you have a look here, the connectivity for the top two layer and the below two layer, the connectivity is what we call it, landscape. Alright, horizontal, vertical. Okay, so tengok kat sini lah. So if you connect here, then the other end will able to receive the connectivity. But for the middle two layer, which is the big one, right? Yang this one, the middle, this one, and this one, the connectivity is up to down. Meaning that if you connect on A, ada huruf ke? Ada. If you connect A, then it will be connected up until E. Right? Faham ke? Right? So meaning that from here to here, we no need to have a jumper. But if you want to go beyond the border, here to the middle one, you need to have a jumper. Right? Right. Same goes with the second big layer. Sini. So the connectivity is like this. Alright? Boleh? Okay? So far so good. Up until we connect the component. Right. So let's say that we want to connect LED. Right? Either doing like this, or you can choose to be side by side. Right? Then usually we will take the power from the top two layers, right? And the ground also we will take from either top two layer or the bottom two layer, right? That's why when you see the breadboard, there are plus and minus symbol. Plus for positive, where you supply the power, then minus for negative, where you return back the power. Alright? Okay. Boleh? Alright. Okay, kita tengok. Alright, so this is the example if you connect in series. Right? From one end to another end until ground. Okay? Contohnya macam ni. From here, you should connect the power. Then you put a resistor. Then you connect the LED. Then you connect to here and go to the ground. This is series, right? Okay. Then this is how we connect in parallel, whereby all LEDs will collect at the same power line. Okay, boleh? Alright, okay ke so far? Alright, okay, good. Have you learned this before? Kemahiran hidup tak ada ke? Got ah? Okay, alright. So, yeah, no, this is not going to appear in your final exam, don't worry. But I would like to highlight here that the difference between series and parallel on the component failure. On series, if one component fails or is disconnected, the circuit is broken. Alright, or disconnected. But on parallel, if one component fail, the other component continue to work. Right? But when it applied to bulbs connected in series become dimmer as more are added. Bulbs connected in parallel maintain brightness independently. Right? So this is the major difference. Yang lain tu bolehlah baca. Right? Okay, done. Then we have, I think this is the last theory part. Signals. Yang ni banyak dah Dekat subjek IITA ada mention about analog and digital. In networking ada analog and digital. Lagi dalam apa? I believe computer architecture pun mesti ada juga analog and digital. Banyak subjek dah cover analog and digital. Right? So the difference between analog and digital is analog is continuous. Right? Digital is discrete. Okay? Kalau if you have a look here, meter ni it can stop anywhere between 0 and 1. It can be 0.1, 0.2, 0.3 or 0.11. It can be very precise, depend on the needle, right? But if digital, it is discrete. It is either 1, 2 or 3, for example, right? As we know that digital consists of binary number, 0 or 1. So all those knowledge that you have learned, I hope that always be with you lah, because we're going to use it a lot today. Jangan lepas final exam je, oh hilang, tak tahu dah analog apa, digital apa, tak tahu. Okay, so it is not just for your final exam, it is for your skills. Alright, so this is the difference. In terms of signal, this is the difference between analog and digital signal. Right, so as we know that digital consists of binary lah, 0, 1, 1, 0, 0, 1, right? So for example, kita punya lampu ni, either on or off. Dia tak ada in the middle, tak ada. Right, but analog can be at the middle value. Okay? Tak apa, kita tengok. But this what I can promise to you, that what will we produce today. I will prove the concept of analog and digital. Okay? So, if the wave like this and digital like this is not necessarily remain like that. It can be any pattern. Right? It can be like on, lama, off, kejap, on, lama. Right? So as you know lah, let's say that binary 00001, meaning that 0, 1, right? Okay. So same goes with analog. It can be any pattern. Alright. Siapa pernah belajar Arduino? No? No one? Alright, okay. So this is a pretty famous board that they use it for development, right? Smart development, okay? Right, so we are not using this board, but we try to compare with Arduino. For example, over here we can see that analog A0 up until A5. So there are dedicated pin for analog, and we have dedicated pin for digital, right? Yeah, there are number of pin lah, banyaklah digital analog. Then we have 5 volt, 3 volt and ground. Okay, this is Arduino Uno. Alright, so basically this of thing that we going to apply to our board. Alright, maybe boleh tengok lagi kat dalam ni ada apa? The one with a red sponge. Okay, so this what we call as ESP32, right? Okay, so it has 38 pins, I believe. I did not count actually, but I believe it is a 38 pins, right? Okay, then it has more analog input, right? So ADC. ADC stand for analog digital converter. So basically it will convert analog to digital signal, right? Right, so we need to take note on the pin number, GPIO number. 36, 39. Kenapa? Sebab one of the reason kat sini tak ada label, right? You can see at the back. Kat belakang ni baru ada label, right? Kat depan ni tak ada label. Unfortunately, when you plug into your breadboard, you are unable to see the back. So you need to refer to this diagram, right? Okay, right. So we can see that the first one is 3 volt. The reset button, then we have our GPIO 36 until GPIO 12. Then we have our ground, then continue on other GPIO. Right. So the one that don't have ADC, meaning it is digital. For example, GPIO 22, 23, 1, 3, 21, 19, and so on. That is digital. That is for digital. Okay. All right. Okay. Try to plug the ESP32 as to the breadboard. Right? Okay. Make sure that the connector of the cable, right? Okay. At the end, easy for you to connect. And when you plug this, make sure there are one line hole here and one line hole here. Is it okay? Sini. Okay. No. Betul lah tadi. Put it here. Betul? Boleh? Okay. Cabut kabel dulu. Unplug the cable first. Careful. Okay. Macam ni. Okay. Betul? So make sure ada satu line free. Okay. Alright. Okay, you can press evenly. Perlahan-lahan tekan sampai dia masuk. Alright, good. Okay. Tu tak tekan lagi tu. Why? Can? Alright, okay. So, dah? Every one of you dah? Bentar lah tu. Macam ni, pelan-pelan tekan. Then, like this. All good? All become like this, yeah? No chat. Must be like this. Very close. You just need to maybe take out this wire first. Dia kena macam slowly lah. Tu. Okay. Alright. How about girls? Okay, done. Alright, okay. So, dah? Berjaya? Right. Boleh Semua dah? Okay, done. So, from now on, this is your thing. Right? So, we will develop what we want to measure on this thing. Okay, another component. Kita tengok apa lagi ada dalam ni. Ada tak LED? I believe Miss Maisara put the red one. The small red one. Ada tak? Tak ada? Ada ke tak ada? Alright, okay. So this one you can put maybe on 30, line number 30, side by side. Please be gentle with the breadboard because it is new. Ni macam ni Okay, good. Put it like this. Boleh. Any also can. Just put it side by side lah. Okay. Never mind, just try. Like this Mr. Chin. Panjang positif. Tak kisahlah, cucuk lah. Ingat je lah nanti. Dah. You okay or not, Din? Yeah, like that. Slowly, slowly push until going inside. Side by side. Tekan semua. Never mind, put the LED first. Alright. How about you? Yep, correct. Okay. Okay, done? All good? All good? Okay. Alright, so, but please remember which one is the positive, right? Positive going to be the anode. The LED basically has two legs. The longer one is the anode, meaning the longer one is positive, the one that receive current, right? Okay. Dah kena buka balik, tak tahu mana satu. Buka lah. So the long one is positive. Okay? Tak kisahlah if you want to put on your left ke right ke, it's just that you need to remember, right? Or you can see the small one is the positive. Lemak. Okay. Small one Maksudnya yang small ni kan, kalau tengok betul-betul, if you have a closer look like this, you can see that the small one is positive. Right? The flat is negative. Right? Boleh? Boleh? Betul. Okay, done. Right. Okay. So, done. Boleh? Ada apa-apa masalah? Tak ada? Okay. So, should we move forward? Okay. Jap, minum jap. Alright. So, I will not go into detail how LED works, how this work, how that work, right? We just briefly get an idea, then we apply to our project. Right? Basically, it has a bond wire. There's a very tiny wire that will bright up. Okay? Macam, let's say that you have a steel rod, that you put a high voltage, then the rod will become red and will melt, right? So that is the concept of LED. They are the bond wire that will bright up. But if you put high voltage, it will blow. Okay, so another component. We take this. This what we call as the middle one. The middle one. This what we call as a potentiometer. Right? Basically, this is a resistor. But the value can be adjusted. Right, so this one maybe you want to put beside your LED. Okay. Like this. Ini tak buat? Like this. Okay. Jangan dekat. Boleh lah. Like this, side by side. Boleh. Never mind, just push it a little, I will go in. Boleh? Dah. Enough lah tu. Right, like this. Done. Oh, sin. Tak kisahlah. Jadi, nanti jumperkan je. Can? Never mind, just put beside the LED. Carefully push and make sure it going down. Yes, correct. Is it strong? Okay. Patah sudah.
Like this.
Never mind. This is the learning curve.
Oh.
Yeah, don't need pliers. Okay. Right? Okay. Alright. Okay. All good? Yep. Alright, done. Alright, so this is where we use to produce, guys, hello. This is what we use to produce analog signal. Kenapa? Sebab when you toggle it, it has continuous toggle lah, right? Okay. If LED, dia ada on or off only. But by using this, kita ada value, kan? Kita boleh adjust. Kat mana selalu nampak ni? When you use this kind of thing. Dekat mana? Apa dia? Dekat mana? Kelvin, dekat mana? Kipas. Mana ada? Kipas macam tek, tek. Itu binary. Yes, speaker. Correct. The volume. Apalah. Alright. Speaker Okay. Kat mana lagi? Kereta kan, pedal minyak. Kereta tak boleh binary Kereta binary, tak boleh macam tu. Dia kena ada continuous value, right? Aircon pun binary. Okay, so right. So this what we use to produce analog. Alright, so when it goes to sensor, right? Most sensor or almost all sensor will come with 3 pin. The power, the ground, and the signal. Right? So, why don't we have a look on the sensor? We have two type of sensor. This one, this is not the fork, yeah. This is sensor. This is water sensor, right? It comes with the cable, 4 cable. Right? Okay. So this is one of the sensor. Then we have another sensor, which is this one. Kita ada dua sensor for this thing, right? Let's have a look. Rasanya ada yang tak ada jumper eh. Oh, yang ni tak payah jumper lah. Okay. Ada eh? No, that one. No. Yeah, that one. The difference is, that one is female to male. This one is male to male. So we should use 4, right? So there ada extra satu. Take out this. Take out the green one. Yeah, take out. Just strip. Okay. And then connect to the 4. Okay. Boleh. Okay. Ni, ambil kabel ni. Make sure it's female to male. Betul? That one is male to male. That one. No. The rainbow color. Okay, this one is female to male. So we only use 4 cable. So there is 5. Take out 1. Let me. Right. So this is 5 cable, right? 1, 2, 3, 4, 5, right? So kita tak pakai, kita take out satu. Right? So this one you can connect to this. Okay. Now. Oh. Yeah, correct. Okay. Take the rainbow cable. Okay, take one. No. This one is female. That one. Male, female. Itu berapa kabel? Kira. 4. 4 what? 5. Take out one. Take out one. Tarik. Tarik. Take out, yeah. No need. Any also can. This one no need. This one no need. This one. The water sensor. Right? Boleh? Boleh ke tidak? Boleh ke tidak? Alright, so the reason why we need extra cable for this, because we're going to play with water. That's why we need extra long. Alright. Then I would like to have something like this. Okay. Put on your breadboard. Okay. Okay. Can? Good? Right, good. So connect to the breadboard. Yang ni jangan macam ni. This one, you need to be side by side like this. You cannot like this. You need to be like this. Because one for power and one for grounding. And this one, it is better for you to have this side. Because easier for you to toggle. If like this, you hard for you to toggle. Okay? Alright. Okay, then this one you can connect. Never mind. You just connect. You just connect to the board. Any of it. Doesn't matter. Okay. This one also. Any of it. Okay. Right. The reason why I put it side by side, easier for us to see. Yeah. Yes, can. Okay. Boleh? Kenapa? Why? Okay, macam ni. Tengok This one, you just take out. Just take out. No worries. This is just a jumper. Right? Okay. Then this four, we use it here. Okay. So going in. Done? Okay, done. So this one, you just plug in. Yeah, plug any four. Right? Over here also can. Betul? Mr. Chin? Okay. Alright. Tu, LDR sekali. Okay. Put your sensor to the board. Grace, okay or not? Okay. Just put beside the potentiometer. No harm. On the right side. Yeah. Boleh? Okay. Slowly. Slowly. Done. Put. Yeah, just plug in. Yeah. Okay. Okay. Alright. Then the other four. No. It's just that after later on you need to refer lah. Four. I think four. Mm. Okay. This one. Yeah, correct. Then LDR. New one also you connect one line lah. So that we can test one by one. Okay. Right. Din. Dah bergerak dah semua orang. Okay. Hey, what's wrong? Take picture. Oh, you need this, right? Okay. Let me send you the slide. Wait. Alright, okay. Sorry. I should provide to you the slide. Let me check again. Where is it? This one. Present. Alright, okay, save what we call it, ESP32S pin out. Right, so basically in every PC, right, you will have Microsoft Teams, right? So under Microsoft Teams, under Teams on the left panel, you can see I already create IoT training, right? So when you go inside here, you go into file, you can see the class materials, right? So anything I should put it inside here. For example, Terence nak apa tadi? Pin out. So I will put it there. Okay, there you go. So you can see the pin out. Might not clear as my slide, but I think this will do. Right? Boleh? So any file sharing, I will share it here. Right, before that, let me download and give it to you. Dah connect dah side by side. Alright, kejap Okay, so I will provide this slide to, sorry, salah. IoT slide here. Okay. Right, so you can refer to the slide, you can refer to the pin out and so on lah, up to you. Right, so I believe there are one more sensor, am I right? It's not a sensor actually, it is a push button. Kan, the red, ada tak? Kan yang boleh tekan ni, tek. Alright, this one also you can put side by side. Beratur kan dia. Beratur kan. Just letak je. Just be careful lah. Kadang-kadang dia tajam. Okay. Cuba tekan. Boleh tekan. Okay. Alright. You guys? Ada. Push button. This one letak sebelah-sebelah macam ni. Alright. Okay, nice. Okay, Mr. Chin. Then? Okay. That one, LDR? Just put it one line lah. Put the button. Okay? Put sini boleh. Boleh? Ini empty space lah. Right. What's up? Okay, you redo again, is it? Yeah, just put it in one line basically. Just put it in one line. Huh? All of it. All of it. 1, 2, 3, 4, 5. We will have more LED afterward. TS sama? Okay ke? Oh, kabel HDMI kat sini juga. Aduh, kelak kabut betul. Alright, guys. Everything is good? Okay. Done? Alright, good. Okay. Alright. Yeah. Ada lagi ke? Tak ada dah. So dah tak ada Basically we have plugged all components. Right? Okay. Okay. So you have your mail to male jumper, right? Male to male meaning that both side is a pin. Kan? Both side is a pin. Alright. Do you have a black color? Ada black color tak? Ada? Ada. Okay, good. Right. So that black color, we put it on ground. Ground So tengok kat sini kan. Pin kanan atas sekali. Top right. Ground. Okay. Sini. Beside the pin. Correct. Betul. Okay. Boleh. Slowly. Okay. Then you connect to the negative. Here can, here also can. Up to you. Beside the pin. Okay. Beside the pin. Boleh. Okay. Tak kena tu. Beside the pin. Cabut. Ya. Ground ke ground lah. Kita buat terminal dulu lah. Sarah. Ni ada. Saya pembantu. Ground to ground. Negative. Very clever, Mister. Okay. If you don't have, you can use brown. Yeah, brown also can. Tak apa, never mind. Ni black ada. Just take it out. Later kita nak separate pun. Mana? Pin, first pin on the right. Beside to the ground. Boleh? Okay, good. Bisa? Okay ke? Okay. Take out one. Use brown lah. Pull. Yeah, pull. Then the first pin, beside the first pin, on the right side. Okay. Yeah, connect it. Yeah, to the negative. Yeah. Okay. Done? Which one? You try to make it. This one, is it? Yeah, same function. Tak buat? Sarah tak buat? Dah? Okay. Take it out. Trip it out. Marah. Okay. Put beside the first pin and to the negative line. Kenapa yang this? Okay. Suka Sarah. Negative. Ya, boleh lah. Okay. Right, done. Yeah. Done already? Okay, good. Right, so you guys okay? Connect to the negative, the blue line. Negative. Alright, let me see. No. Here, on the top. Take it out. Yeah. Here, where? Boleh? Don't pause. Let me. This one. Sini. Okay. Alright, okay. Alright. So, when there is negative, there always be positive. Right? Like you lah, like you and your partner, right? Girlfriend and boyfriend. Right. So, positive dekat mana? On the left top. So, we have our ground, then we need our power. So, sama juga, we put it here. For me, I would like to separate the terminal. Okay. Tengok ni. Beside this one. Yeah, correct. Betul. Okay. Then connect to the red line. Yeah, yes, correct. Okay, done. Done? This one? Done? Okay, good. Sichin, okay.
BCC ah?
BCC, okay. 3 vote, Yeah, 3 vote. Okay, positive? Yeah. Usually red. Positive, usually we use red. Positive, you usually use red. Never mind. Same. The function is for jumper is just the same. On the opposite, yeah, for the positive. Huh?
Positive.
Yeah. That one is for AC. For DC always positive and negative. Yeah. Hmm. Okay, done. All right. Okay, done. So basically, we already supply the power. All right. All right. So basically, I hope you guys still have about 3 cable more. Right? So these two we connect on LED. Right? Okay, LED kan ada dua kan? Right? So the positive one will go to the positive, then the ground, the negative should go to the negative. If you did not remember, you can just take it out back. Yang ni kan LED, right? Ada dua kabel. Brown to the not necessarily purple lah. On the left side, go to the positive. On the right side, go to the negative. Okay? This one, LED, right? So, two cable, one cable to the positive, one cable to the negative. Side by side. Yeah. Never mind. The color doesn't matter. As long you remember. Right. For example, right? As I said, yang this one, the current move like this, right? Okay, over here, the current move like this. Right? So if you take out, which one is positive? This on the long one. Okay, long one is positive. So current will flow this line. This line current will flow, right? So you can just choose one and put it on positive. Okay, then another one you put it on negative. Okay, mana? Never mind, one by one. Done. LED. Take out two jumper. You cannot, yeah. Take out first. Right? Okay. So, which one is positive? Confirm? Okay. So, the current will flow this line. Right? This line. So, you cannot put it here. Nanti current tak flow. You must put it in this straight line. Any of this lah. Sini boleh, sini boleh, sini boleh. Okay. If this is the positive, then you connect to the positive line. Okay. Then the other one must be negative. Then you put it in negative. Boleh?
Okay.
Okay. Then
Satu.
right, okay. Guys, so breadboard works in this way. The middle one, the current will become Kevin. Weh, kemah weh. Nak scan. Alright. Okay. Alright, come here. So take out, yeah, this two. Never mind lah, we separate it. Okay. So this is LED, right? So LED basically has cathode and anode. The long one is anode, which is positive, which is we should supply the current here, right? So we put it this way. Am I right? So yang positive tadi tu should be connected in this line. Any of this line, current will flow. If you put it here, current will flow here. If you put it here, current will flow here. But if you put it here, current will not flow. If you put it here, current will not flow. So you need to put it straight line. Then you need to jump with your positive. Same goes with this line. Any of this line, current will flow.
Here also.
Here also, yes, correct. Okay, so I just put it here. Then the other leg should be connected to
Negative.
negative, right? So sama jugalah. Then you, yes, correct. Boleh?
Betul.
Hmm. Tengok. Ya.
Pendek punya negatif mah.
Pendek punya negatif. Okay. Alright. Okay. Betul. Right. Okay, kita nak tengok circuit kita betul atau tak. Try to connect the board. Right, try to connect the board. LED siapa yang tak menyala kena belanja lunch. Alright. Okay, try to connect the board and you will see your LED should be light up. If not, meaning that something wrong with your circuit. Okay? Boleh? Nyala lah tapi malap-malap. Nyala. Negatif tu mana? Yeah, negative should be with the black. Why with the white? Yeah, with the black. Yeah, side by side with the black. Yeah, correct. Blue tu put side by side with the white. Yeah. No, man. Boleh lah tu. Menyala sikit-sikit tu okey lah. Yours? Why? Tak apa, tak apa. Biarkan dulu. Kenapa?
Ini aku dah terbakar.
Confirm tu bakar? Lah kan? Tak akan resistor kan? Apalah. Okay. Alright. Never mind, never mind. Alright. Okay. For those yang dah terbakar LED tu, kita hold lah dulu. Nanti kita ganti. Alright. Okay. So, next thing. Ya. Alright, okay. So next thing that I would like to do is Arduino IDE. Alright, Neman, yang wire tu biar dulu. Okay, maybe kita kena ada program kot, baru nampak sikit lah. Alright, kau berapa dah ni? 10.30. Okay, you can open the Arduino IDE inside your PC. So you can see mana ni? Let me try. Oh, dah. Okay, lambat sikit kot. Semua orang semua orang. Individually, you need to write a code. Right? Okay, so basically, you will have this kind of interface. Is everyone having a same interface with me? Yes, alright. So, there are two category or two body. Right, okay. Right, if you do your programming right, C++, what you will start with what? Usually we will start with hash include IO stream. Am I right? Then we have our in main. Then we have our function lah. If you have, betul, right? But in our Arduino IDE, we have our loop, void loop, and void setup. This one is setup. Okay. So in C++, usually we call this as a function. No argument, no return. This is just a blank function, right? So we have two function body. First one is setup. The second one is loop, right? Okay. So what is the difference between these two body? Apa beza dia? Loop and setup. Okay, for void setup, it only run once. You turn it on, you program, it will run only one time. But for loop, it will repeatedly continue. Alright? Alright, okay. So kita program sikit lah Alright, before we program, we need to select our board. Tools, port, and port 9. Okay, maybe some of you has multiple ports. Ada berapa ports? Satu je ke? Com berapa? Com berapa? Boleh? Com not necessarily same with me ada satu dengan tiga. How you want to choose? Okay. Alright. Maybe, I think most of you has more than one, right? So what you can do, you can type device manager, then you can open, yeah, it will from this, never mind, just okay. You can select under port, this one, Silicon Labs, mine is COM9. So in Arduino IDE, we should select COM9. COM3, kan? Okay, so over here, tekan. Okay, select board, COM3. Alright, okay. This one, ESP32, type. ESP32. Oh, tak ada. This one, click. Okay, okay. Boleh? COM, are you sure the COM is correct? Okay. COM, select, yeah, that one is COM3, yeah. Over here, select COM3. Tools, port COM3. Okay, select the board at tools. Board, ESP32. ESP32 develop module. Yes. Okay, Mr. Okay. COM3. Okay. Yours? Dah belum? Tools. Board. Select the board also. Board. Select the board. ESP32. ESP32 development module. Yeah. Down. Yeah, tu. Okay? Sudah? Wah, sudah type. Hah? Hah? Kenapa dah banyak terbakar? Oh. Arduino IDE. Ya. Open Device Manager. Okay. Start. Eh? Yes. Scroll down. Kenapa tak jumpa? I take out first ah. Okay. What? Tu. Short circuit ke apa? Okay. Test from 3. So over here, you just need to know the tool. Tools. Port from 3. So tools. Board. SPT2. SPT2. Yeah. Develop module. Dev. Yeah. How about you guys? Okay. Right. Okay. Okay. Right. So make sure that you select the correct board. Alright. So next thing. Alright. So instead of positive LED go to the positive, we try to make it. We try to put it in what ah? Kita tengok jap. Kat mana pin yang best? We try to put it GPIO. GPIO berapa eh? 22 lah. Boleh tak? 22. Right? So instead of going to the positive, we go to GPIO 22, which is number 3. Okay. Instead yang this one, belum kan? Just now dekat sini. So you replace it here. Yang positive. Let me type. Let me have a look. Right? So this one, you take it out. Okay. You connect to 22. Right? Pin number 1, 2, 3. Right? So beside that. No. Here. Move. Lagi. This one. Over here. This is ground, right? This is 20. This is 20 what? 23. This is 22. Tengok yang ni. Okay. 22. This is 22. Betul? Okay? Okay. Right. Oh, yeah. Yes, correct. Your ground dekat mana? No. This one remain here. Yang ni, this one. Ni positif ni kan? You put it 22. Boleh? This one. No, this one remain here. This is always ground. This one. Put it at 22. Terbakar lah. Nah. My sister. Kunci kat depan. Tak payah. Kita rebel lah. Nah. Ha.
Okay. Terbakar tadi.
New bulb. Ha. Alright. Okay. Done. Not yet. Okay. Mana? Mana? Sudah?
Belum.
Okay, this one is positive, right? Positive ni take out. Okay. Connect to 22. Mana? Kaya, tolong. Pin number. 22. Okay. Right, done. Good. Okay. Alright. Pakai lah. Nak pakai. Pakai lah. This one, positive ni, you unplug and connect to 22. Pin number 22. Do you know which one is 22? This one over here. 22 here. Pin number. This is ground, the one that you connect. This one, right? Okay, then connect 22.
So correct.
Hmm. The positive LED. This one. Connect. Cabut lah. Connect to 22. Then boleh 22. Your LED burn already. Oh, why? What happened? Experiment too hard. Okay, connect. Which one is positive? Remember, which one is positive, which one is negative. Alright, okay. Done. 22. 22 done. Okay. Alright, okay. 22 mana? No. This is remain here. This is the positive. The positive go to 22. Okay? Okay. Sekejap, tengok. Dah terbakar ke belum? Fine. Yours? Okay? Okay. Alright, done. Okay, done. Alright. Okay, so for this part, I need to sit down. Why? Mana? Where is my board? Okay. Tertinggal pula. Alright. Okay. Right. Let me connect back my cable. Connect lah Connect. Tentang. Alright. Make sure 22 Nak lain pun boleh je. It's just that you need to remember lah. Right, so we open our IDE. Let me choose my board again. Alamak, salah. COM9 board. My board name is ESP32. Okay, so this one you can refer to the slide. I already put the example. But this one dia nak 16. You can choose to move to 16 or you can remain at 22. Up to you. Right? As long it based on this what we say? This pin out lah. Okay? Right. So let's say that we remain at 22. Then we refer to the code. Right? So this one you need to write it by yourself. I did not provide the code. Alright? Okay. Usually, this one comment ni I buang lah We do not need this. As we know, we have two body. Right? Usually when we write a program, on the top, we should write the library or the declaration. So over here, I would like to declare LED1 pin number 22. Right? Then over here, I would like to make the LED1 as an output. Okay? So, meaning that we saying that LED1 located at pin number 22 and it is an output. Let me zoom. Can I zoom this? How to zoom this? Control and plus. Alright. Okay, thank you. Alright, okay, done. So basically we have declare. Right, in Arduino IDE, you can see that functions will be colored orange. Right, orange or red lah, something like that. Right, macam ni, function setup, color orange. Function pin mode, color orange. Loop, color orange. Right, if you type pin mode and it is not orange or red, meaning that you type it wrongly. Okay, for example, let's say that I put 0. Orange juga ya. Pin mode. Okay, so you need to do it correctly. So as an output. Dah. So if the normal, I would say, switch, right? We just turn it on and then we turn it off. Inside program, we need to use their own function, which is digital right. LED1 high. Okay? Done. So maybe you can save it as, I don't know, you can name it. Maybe 0101 LED. Oh, tak boleh. 01 je lah. Right? Okay. Done. Right. So if you are done, you can you can check again ESP32 development board, development module connect on COM9. So you can verify and upload, or you can click upload straight away. So this is a button. This is verify button. In your C++, right? They call it as a compile. Right? So it will compile. Is there any error? Is there any missing semicolon? Is there any mistake on your programming? Then you can press upload. Upload is sending the program to your board. It's going to take some time, yeah. Okay. Pakai color putih lah. Color putih macam reliable sikit lah. Color merah macam tak best. Is it okay? Let me change this for you. Yang merah tu letak dalam ni. This one? Done? You dah verify? Yang tu connect ke PC dia. Let her do first. Huh? Take out the red one. Put it here. Tak payah pakai lah. Positive. Okay. I think better. Hey. Okay. I think white is balik red. Sudah terbakar. Try to change high to low and program it back. Ya? Upload. Tu sebelah ni. Kanan. Upload tu maksudnya dia masuk sini kan? Tengok menyala tak menyala. Tak menyala ke lu? Something wrong lah ni. Kena mandi bunga. Menyala. Tukar low balik. Tukar high ni. High ni maksudnya on. Tukar low. LOW. Tekan upload balik. Dia boleh. Dia boleh taruh upload. Dia padam. Tak, aku tak tahu. Sebab putih kot. Okay. Oh, dah ada resistor pula.
Surat ada.
Use white lah.
Use white.
White is better. Dah?
Plugging the 22. So I put 22.
Yeah. You connect 22, right?
Yeah.
22. Okay. This one digital right high. Not output. High. Yo. Tukarlah LED. LED tu tak bright lah. Use this one. This one positive. This one is negative. Okay. So positive should be the long one. So the long one should be here. Kenapa ada resistor ni? Kenapa?
Entah itu.
Okay. Right. Yeah. Change lah. I think the red one is not bright. No pot. You. No. Tools. Select again. You sure? COM3. Okay. Alright, okay. Alright. Done? Okay, menyala tak? Menyala? Is it okay? Okay. Try yours lah, cabut. Connect yours. Okay. Wait. Change to low. High, change to low. Okay. Upload again. Tengok dia padam ke tak padam? Okay. Alright. Okay. You guys? Okay. Alright. Okay. Okay. So basically, this is binary, right? So when you put it high, it will turn on. If you put it low, it will turn off. But let's say that you put 500 millisecond, then digital, right? LED 01 low, and delay. Okay, let me stretch out a bit. Okay, so basically, I want it to be turned on for 500 millisecond and turn off for 500 millisecond. Since it is in a loop, it will start blinking. Okay. Okay. Cuba tukar 500 jadi 100. Hmm?
I should save. Oh, and
Up to you lah.
upload. Yeah, I just save as.
Kan? Just save lah. Already have date here. Hmm.
So when I run, I will be like.
Why got error?
We have some. Not declare.
This one LED 01. But you decline. Okay. Okay. Upload. No check. That one just compile. This is for compile. This one for upload. When you click upload, then it transfer there. Right? Okay. Should be. Fail. Kenapa fail? Short circuit ke? Kenapa? This one no need. Okay. Sekali lagi. No, upload. Ya, upload terus. Tools. Bot. Bot. SHP32. Just this one. Okay. Try upload again. Baru okay. Tadi ni short circuit dah. Careful. Okay. So, over here, enter. Delay. Continue lah. Okay. Then. Okay. Right. Upload to your WhatsApp story. Okay. Huh?
Oh, sorry.
What was it? What is the error? Digital right. LED high. Right W besar. Okay. Try to upload again. Oops. Wait. Okay. I don't know. I think if you put it straight away, it is brighter. You see? If you did not use the resistor. Right. Okay. Right. Nak take 5? Right. So we take 10 minute lah. 10-minute break. then we will continue. All right, so please be back around 11:20. Yeah, 10 minutes. So what, 50?
Ada register. Saya rasa umur.
Malap, tak best. Aku rasa putih lain lah. Putih dia tahan sikit.
Dia okey kan? Rosak.
Tak, aku rasa kalau macam putih, dia punya wire tu tebal sikit. Sebab dia nak bright kan. Temperature dia tinggi sikit kot. Aku tak pernah pakai je LED merah. This one berapa millisecond?
15.
Okay. Nafisa okay kau? Macam bosan lah. Kena besar. Tak apa, tak apa. Dapat apa?
Dapat certificate.
Suang saya sediakan. Sekejap ni dah pernah kot. Jadi kau kan mekatronik. Baca KM komputer ke? Ada komputer tak tahu. Macam mana? Ha? Ada. Dia bagi tahu aku lupa. Macam mana Di KM pernah sentuh dah. Diploma kita. Timbal. Jadi bola. Tu range system berapa sekarang? Ush. 2-2-0 lah. Tak apalah.
这是它存在的那个时间。
Alright, alright.
SP itu 30 bit.
16.
16.
Alamak, aku tak ingat lah.
Kalau kita ambil analog input kan, dia punya
Oh, analog input dia 12 bit.
12.
4095.
Dan dia punya bit tu kan
12 bit.
12 bit lah. Banyak orang takat kan 256 je lah.
4095. Itu yang apa? Bila aku nak minta MPTT pakai Arduino kan. Oh, Arduino obsolete lah. Okey, bolehlah menjaga barang kita tak syok tak puas malap-malap je. Hmm. Terima kasih. Ha? Uh, uh, uh. Alright, okay. Done? Okay, shall we continue? Alright, okay. So, if you refer to the slide number slide number apa ni? 28. Right? Okay, so since we have our push button, then we should connect to our ESP32. So basically, if we have our LED on and off, right? So that one is digital. Digital. So we have our LED on or high. Then we have our LED off or low, right? So this is 1, this is 0. So this is the concept of LED, right? And this is as a output. Right now we have our push button. Right? We have our push button. Then we have 3 pin. If you have a look at the push button, there will be VCC, ground, and what? Out. Betul tak? G and D, VCC, and out. Tengok, betul-betul. Have a look, have a close look. Kalau tengok ni kan, push button ni tengok. Ada G and D, VCC, and out. Boleh? Okay, tengok betul-betul. Okay, done. So, dah tengok betul-betul. Then, we need to connect. So, we have our breadboard, right? Okay, so basically yang sini positive, ni negative. Then, we have our ESP32. Ground connect to the negative. VCC connect to the positive. Out connect to the pin number. Alamak, salah. Pin number berapa? 17, 16. Connect lah mana-mana pin. 16 lah. Connect 16. Okay? Tahu ke connect pin 16? This one. 16. Mana 16? 16 ni at the middle. Okay, kira berapa? Daripada bawah berapa? 1, 2, sekejap 1, 2, 3, 4, 5, 6, 7, 8. 8 from the bottom. Okay, sekejap. Siapa yang tak cukup jumper bagi tahu Okay. Hah? Nah, ada 1, 2. And the last one. Okay. Ada jumper. Nah. Itu female ke?
Tak ada.
Okay. Ada jumper? Tak ada jumper. 3. Okay. Ada jumper? Nah, 3. Jumper? Perlukan jumper? Ambil dah. You got jumper? This one. Use this one. You need to use 3. Mana Kelvin ni? Hilang pula. Okay. Dan? Boleh? Tengok ni ya. Okay. Tak okay. Mana tak okay? Meh sini. Macam mana? Alright. Okay, this one. Kalau tengok dekat sini, satu ground, VCC and out. Am I right? So, you can connect either this way or this way, doesn't matter lah. Okay. So, jumper. Take it one by one lah. Right. So, for example, kat sini, ground. Kita ambil color brown lah. So, any of this line should be ground. So, you connect. Ground dekat mana? Kita letak dekat-dekat lah ground. Betul lah? As you said. Then, another one. VCC. Power. Kan? Okay, power dekat mana? Betul. Dekat sini. Okay. Then, another one is out. Out should be pin 16. Connect lah pin 16 kat mana? Cari pin 16. Tapi macam ni, susah lah you nak tekan. Kan? So, either you put it like this. This one you put it here. Sini pun boleh. Okay. Dan ni senang lah nak tekan. Okay. Okay. Betul. Ground. Ground mana? No. This is what? This is ground. This is your ground. You should put beside here. Okay. Betul lah. 14 pun boleh juga. 14? Mana ada 14? Okay, that one? This one? Betul. The yellow one is out. Is it? Out is pin number? Okay, good. Is it okay? Oh, very fast is it? Okay.
转进来啊！你很差很差。
Alright, okay. All good? Alright, so. Okay, here we go. Lajunya. This one cannot. 22, 22, 16. 16, right? Okay. I think. Okay, betul lah. Serial monitor. Tukar baud rate dia. 1, same with this one. 115, 200. Dah, 1. Press the button. Dan tengok. Press hold. 0. Okay. Open this one. Press the button. Hold. Okay. Hold. Press. Hold. Kenapa tak hold? Tengok ni. Okay. Macam ni dulu kan? So this is 1, right? This is 1. So I press hold. This is 0. Okay. And I release. This is 1. Okay. Hold. This is 0. Yes. Ni kan digital. Right? Okay. Then. This is negative VCC. Alright. This is 16, is it? Yeah. Okay. Dah. Ikut. Open your serial monitor. Change the baud rate. Same with this one. 115 to 100. Okay. 0, 1. Kenapa tak tukar? Hold. Hmm. I think this one 16, right? Change 16. Ni example lah. Okay. Hold. 0, 1. Release 1. Okay. Open your plug. Okay. Let it be. Okay. Hold. Release. Hold. Release. So this is digital. Okay. Right. Okay. Alright. Okay. All good. Ladies. Done. This one. Okay. This one is what? Negative. This one is power. Okay. Betul? Okay. Cocok. And try to do this. Okay, yang ni kan? Okay, for example, tambah. Define. This one. Define. No, kecil. Huruf kecil. Okay, space. P button. 16. 16. Don't follow this one. This one is different. Yours is 16, right? Okay. Then, so below this, let me okay, type this serial begin open bracket 115 200 close bracket, semicolon. All right. So another one, pin mode button input. Put. Okay. Semicolon. Yeah. All right. Good. Okay. So this one maybe kita letak 100 je lah. You want it to become faster. Okay. Kat sini. Tambah ni. Value. This is variable. Variable use store value. Digital. Read. Open bracket. Push button. So basically we want to read the input from push button. Okay. Alright. Okay. Then kita ada serial dot print. Okay. Just follow. Okay. Open bracket value. Okay. Alright. Done. Okay. So basically this one kita set sebagai input our push button. LED kita set sebagai output. Right? This is pin 16. Your LED is pin 22. This one we need to read the value. Right? So this one we want to show the value. Okay. So kita try upload. Alamak, ada error. Okay, kita tak, apa dia cakap? Value was not declared. Variable value kita tak declare. Cuba tambah ni. Kita declare sebagai, do you know what this is? INT. INT stand for? Yes, correct. Okay. Upload. Done. So you click this one. This is what we call as a serial monitor. Yeah, click. Okay, this one, baud rate. You select same with this one. 115, 115, 200. Okay. Okay, we have 11111. Okay. Cuba press push button, hold, hold. See? Hold. Tekan lagi lama. Tu 0. Release 1. Hold 0. Okay. So when we go here, this is serial plotter. Alright, okay. So hold lama-lama until I said release. Okay, release. Hold, release. Hold, release. So this is digital. Can you put in the middle? Try to put in the middle. Is it possible? Cannot, right? Because it is digital, right? But in analog, we can put the value at the middle, right? Okay. Okay. Meh?
Yep.
Okay. Dah, mana? Dah program belum?
Oh, dah program.
Program. Kembang. Mana slide tadi? Push, satu line tu koi. Push, terkejut aku tengok. Okay. Inilah, dah tambah dah. Okay, tambah. Okay or not? Okay mana? Push button slide. Just copy the code. Okay, this one, no, just introduction. This one LED. This one is blinking. This one. Okay. Right. Okay. Right. Kelvin, Kelvin and Grace, okay? Huh? Dah, settle. You open serial monitor. Dah, on the kanta dah, yeah. Change the baud rate. Same with this one. 115. So there will be one lah. If you hold 0. Mana 0? Scroll up to 16 kan? This one right? 16. Yeah. Yang example tu lain. Okay. So 0. So if you open serial beside that, okay. So you can hold, release. Okay. This is digital lah. Okay. So if you try to put it in the middle, tak boleh lah kan? Macam, how you to put in the middle, tak boleh. Sebab, because digital. Alright, okay. Alright, so digital settle. Input, output dah ada dah. Am I right? So you can, you can setting it up. Right? Alright. Okay. So let me see my slide. Alright, so I did prove to you that the digital signal produced like this, right? No other way around. If you try to push the button and become at the middle to provide the middle value, it cannot be done. If you try to provide 0.6, cannot be done. It's either you touch it and release it, right? And this push button, the initial state is 1. When you push it, it becomes 0. So it called as a normally closed. Right? If the initial state is 0 and you push become 1, that one is normally open. Alright, okay. Right, so it apply to a sensor, right? Any sensor will come with this kind of concept, right? So if something trigger that sensor, the value will become 1, right? But if nothing trigger that sensor, it will remain at 0. Okay? So there, of course, there will be external source, then will be ground, current, and so on, and then it will provide the digital thanks to Quadri Electronics. Alright, okay, so right now I want you to do like when the button press, then the LED turn on. When the button release, the LED turn off. Can you do that? Create a new sketch, right? So yeah, create a new sketch, file, new sketch, then try to do a new file, right? So this is the code. Okay, this is the code. Up to you lah, but roughly this is the code. If you want to press, it blinking. If you want to release, it not light at all. Or you want to press a fast blinking, release slow blinking, it is up to you, right? Okay, ni padam lah. Nanti dia confuse. No, this one also? Oh, okay, okay. Serial, buka serial monitor. Okay. Right. Boleh, Vic? Ui, dah ke bawah dah. Dah ke bawah dah coding. Okay. Ada error. Pasal apa? Print. Ni L. Mana ni? L, bukan I besar. L. L kecil, L kecil. Tu print line nama dia. Okay. Try sekali.
Tapi kalau ya ni.
Ada error lagi.
Button.
Ni B besar, ni B kecil.
Oh.
Buatan besar. Okay, lagi. Ni tu boleh.
Oh.
Lepas tu tengok. Okay, nampak macam berjalan.
Tapi yang ni saja lain ni kubur dah ni. Boleh jalan tak?
Mana jalan?
Yang ni saja. Ni.
Ha?
Kubur tu yang bawah ni.
Boleh, boleh.
Boleh kan?
Boleh.
Tak payah bawa setup semua. Kita gabungkan je lah kan.
Gabung boleh.
Kan?
Selagi susunan dia betul, boleh. Okay, dah. Upload. Okay. Alright, sepatutnya ni tak ada blinking lah kan? Ini tak ada blinking. Kita tengok, buka ni, serial monitor. Okay. Yang ni hang tukar jadi sama macam ni. 115, 200 bawah. Oh, atas. Tu. Dia jadi 1111. Cuma hang tekan, hold. Tekan button tu, hold. Dia jadi kosong ni. Dia jadi 1. So binary 0 and 1 lah. Okay. So kalau hang buka ini, okay, hold. Lepas hold. So ni binary lah. Ni digital signal lah. Ni digital signal lah. Cuma digital signal boleh jadi atas on, off sekejap. On, gitu. Depend lah. Depend atas pattern dia. Okay, cuba hang try hold tengah-tengah nak dapat 0.6. Tak dapat lah. Okay. Then give up already. Just doing.
Try something. I don't know how they work, but try something to cook.
Okay. Okay, Mik. If else hang pernah belajar programming kan? Okay. Hang buat if else, tekan dia on. Dia kan macam hang tadi buat kan? Okay, ni pada Mik. Okay, nampak ni besar. Okay, so bila hang tekan tadi dia kosong kan? Release dia one kan? So itu dekat value. Value ni bila dia tak tekan dia jadi one. Bila hang tekan jadi zero. Kan? So dekat bawah ni hang buat if else. If value zero, LED high.
Buat macam tu.
If value one, LED low. Cuba try. Ada contoh kat slide aku ada contoh. Kan? Cuba push button. Okay, release. Okay. Alright. Right, so the code I already include in the slide. Right? So you can refer the slide. But for me, let me Alright. Okay. Okay, done. Loh, tak declare. Oh, Okay. Right, okay, done. So, yeah, when you push the button, it will turn on. Oh, laju sangat, tak ada delay. Right. So, when you push the button, it will turn on. Okay. Boleh? Okay. Cuba tekan push button. Okay. Alright. So yang this one also the same lah. Okay. So this is digital lah. Done. Okay, done. You guys, okay? Done. Terence? Belum lagi. Okay, dah. Dah siap. Tunggu start. Tunggu start, okay. Right. Tak ada. Okay. This one. This one. Push button apa ni? Potentiometer. Sudah ada? Belum kan? Ha. Eh. Oh, dulu hijau. Ha, keliru. So next we're going to do analog. Don't know what happened.
If I set if the value is equal to 0, how like so after I click the button,
What you guys doing?
doing if the button is on, they will like blinking the light. Then
No, okay. Okay, this one. Right. Okay, this one.
it off,
Print
they will
A.
bring A.
This one.
Then blinking.
The value.
Another value because 0, right?
Betul lah.
Yeah, betul. But if the value equal to 1, they will like shut
LED
down
1 lah. LED 0.
0.
LED 1.
But I haven't pressed any button, they come out like this. Why? Suddenly on, suddenly off, suddenly on, off.
Oh, the value berubah. Done.
Yeah.
Okay. Ni apa? Then this one is ground. Okay, this one disconnected at the middle. This one disconnected. So you need to use this one only. Okay, if you want to use this one, meaning that this need to jump. From here to here need to jump. So make sure that you use on this side. Okay. This one for potentiometer. Boring ah, Din. This one for potentiometer. Alright, okay. Okay. Alright. Alright, ladies and gentlemen. Okay, we continue a little bit more before we go for the break. Right. Dah. Shall we continue? Right. So I already provide to you another jumper. I don't know where I leave it. Right. So 3. 3 ah. 3 kan? So if you refer back to my slide, we're going to use potentiometer. Right? So at the middle, we'll go to the pin 39. Middle will go 39. Left will go power. And right will go ground. Right? Let me draw for you. Okay. So this is our potential meter, right? So dia ada 3 pin. So ini VCC, ini ground, and this one is out. Okay? Boleh? So VCC connect to the positive, ground connect to the negative, out connect to the pin number 39 or 36. Boleh? Okay? Ni kan potentiometer ada 3 pin. Any of it, dia tak ada label. Left and right doesn't matter. If you interchange VCC and ground doesn't matter. Right? The only important part is the middle go to the 39 or 36. Kenapa 36 or 39? Why? Why 36 or 39? Because 36, 39, 34, 35, this one we got ADC. Right? So when we want to play analog, we need to make sure that the pin we connect the analog sensor has the ADC. Right? So we connect to the 36. 36 ke? 36, yeah. 36 lah eh. Up to your preference lah sebenarnya. Right? For me, I just connect it into 36. Alright, okay. All good? Boleh? Alright, so yeah. Okay, so the connectivity macam ni lah eh. Satu ground, satu VCC, satu out. Right? Never mind, take your time. Alright. Okay, then this is the code. Meh, tengok. Ada, mana? Mana tadi? Never mind, I will send to you. One or three? Three. Okay. Boleh? Okay. That one to 36. Okay. Ground. Okay. Let's say that one is ground. Just, yeah. Mana satu ground? Yalah. Connect. This one? Connect tu?
Ground to negative.
Ya, betul. Okay, correct. Oh, okay. Another one? That one to the positive. Yes, betul. Okay. Alright, ready to program. Program, refer dia. Refer. Analog input. Ada nak jumper? Any of you need jumper? Yeah, this one. You can create new. Okay. Analog input. No, no. Up, 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 up. Mana ni? Ni. Okay.
So all this delete lah.
Nah, create new lah. Janganlah delete. Nanti new. Okay. You ni hold. Okay, push on the left, to the left. Okay, done. This. Then select this one. Kan easy. This one zoom out. Okay. Where you go missing? Now do what?
Okay.
Done. Sebelah-sebelah ni. Sebelah-sebelah baru baca. Ni hang tarik ke tepi. Langgak tepi ni. Langgak lah. Langgak lagi. Okay dah. Select tu. Tekan ni. Scroll atas. Ni type di sini bos. Selesa. Okay. Right? Okay. Kat serial monitor. Alright, good. Okay. Okay. No longer push button, kita main analog. Okay. Alright. Maximum berapa? Cuba try. Maximum berapa? 4095. Okay, open your plotter. Okay, move macam tu analog. Kan? Analog kan? Alright. Okay. Cuba at the middle. So, try to find 2000. Dah? Almost 2000. Kan? So, boleh lah. Okay. Okay, boleh lah. Right. Okay. Done? Oh, take turns. Is it? Okay. Alright. Okay. Let me see. Okay. Cuba scroll. Yeah. There. Up. Down. Down. Cuba pusing. Tu. So this is analog lah. Before this we cannot meet at the middle, right? Cuba tune sampai dapat 2000. Can we go for 2000? Dah 2000. But we can go higher. Kan? Right? So the value is this. The maximum value berapa? 4095. Okay? Later I will explain why 4095. Right? Okay, let's say that you want to make analog signal. Kan? Analog lah. Kan? Okay. Alright, okay. Ada yang belum ke? Good. See? See? Yeah. Why you combine? No, it is okay to combine, but if you can see, right? This is 30 millisecond. This is 100. This is 300. This is 1 second. So in total, there will be in total delay tau. So it will be lambat lah. Right. So okay. Let's say that mana? Okay, ni serial monitor. Kenapa 101? Oh, this because okay, never mind. Let me comment this one. Okay. So this is the value. Pusing. This one. Potentiometer. You already connect this one, right? Pusing. Twist. Yeah, correct. See the value? Okay, the lowest one. Pull until finish. 0. Okay, boom for a little bit. Little by little, like 200, 600, 10. Up until the maximum? No. Let's see. Berapa? 4095. Why? Okay, later I will explain. Right? So, okay. If you move this one, okay, move. Sebab you delay you tinggi. So, it can be curve like this. Just now digital tak boleh kan? So this is analog. On and off, you have value 0 up until 4000. Go up, back, go up, increase again. There. So let's say that you want to decide the value of 2000. Yeah, over around this area. 2100, right? 2200. So kita boleh lah take the value at the middle, right? So this is analog, right? Let's say the delay is too high. Let's say 100. This one also 100. Okay, tengok So analog lah. Okay, analog. This kind of wave, this kind of signal. Okay. Jadi digital tak boleh kan? This is the difference between analog and digital. Okay. Alright. Jadi, okay. Apa yang okay? Tengok. Combine. Never mind. Delay berapa? 100. Okay. Run. Serial monitor. Not board connected. Why? Port. Okay. Mana analog? Analog tak ada pun. Buat analog. Okay.
Maybe ada wind sensor.
Wind. I'm not sure. Water. This one lah. Okay, alright. The maximum berapa value dia? Apa yang serial monitor? Maximum berapa? No. Kenapa tu 2500 je? Aman? Nanti kita tengoklah. Okay. Miss Long, finally, you got your heartbeat.
Tadi dia punya board salah, jadi tak dapat.
Oh, okay. So the maximum value is, kenapa lain-lain 1200?
1200 saja.
Alright, okay. Ayo, buat apa? Alright. About rate. This one wrong? Okay. Alright, okay. Alright, so dah jumpa. Okay, Vic. Analog okay okay. Alright. Suppose all of you should get 4095 value, right? Maybe some of you did not get that, but never mind. Kita akan have a look. Alright. Alright, so suppose you can get this kind of signal. Alright, okay. Right, so this is the difference between analog and digital. Right? So it can be this kind of form or that kind of form. It depend on the sensor lah. Alright, okay. Dengar sini. Okay, so when we use microcontroller, it always come with digital format. Computer, digital format. Our phone is digital format. Then, when we try to accept analog, there will be analog digital converter, right? So, if you refer back to this pin out, not all pins has analog digital converter. Only few of them, maybe half of them, right? So, meaning that this pin has been designed to accept analog, right? But one of these chip here responsible to convert that value. However, any analog value will comes into digital throughout this converter, right? But that ADC has different bit. I'm not sure either any of you still remember when we have our IP address. It is 32-bit, right? 8-bit, 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 and maximum value of this is 255, right? How I get this number 255? throughout the value of 1111, 1111, you get 255. Right? 8 bits. Right? So it start, of course, it start from 0000. Then, if same goes with our ADC. Right? So if our ADC 8 bits ADC, it will 2 power of 8. Right? So it will equal to 256 value. Represent 0 up until 255. Right? So Arduino PWM using 8 bits. Okay? Then when we turn into 10 bits, okay, to 10, 1, 0 to 4. Right? Okay. Then the value will go ranging from 0 up until 10 to 3. Right? But for our ESP32, they're using 32 bits ADC. So it will become 2 power of 12, which equal to 4096. So that's why suppose you get 0 up until 495. Right? So kalau 12 berapa? The maximum value 1111, 1111, 1111. Okay? So even though it is analog value, but still your device will read in digital. This is what we call as a digital to analog. Right? So this is 0, this is 4095. Okay. Alright. So if we turn into analog, this equal to 3.3 volt. This one equal to 0 volt. Right? So analog measure in voltage. But in our programming, we did not mention as a voltage. We mention as a analog value based on our ADC. Right? So let's say that 5 years onward, maybe ADC already 32 bits. So the value no longer 4000. It become wider, right? So berapa? 2 power of 32. Kira lah berapa. Right? So but this is how we get the value of 4095. Boleh? Ada soalan? Okay, the one that get 1200, maybe it is not, we need to set the resolution to 12 bit. Ada satu function nama dia analog resolution if I'm not mistaken. Analog resolution. This one maybe you need to set 12. Then you can get 4000. Right? Yang the one that you Danny punya 2500, kenapa? I'm not sure lah. That one kena check. Either has need to set the resolution to 11 bit or 12 bit. It depends. Okay? Alright, so yeah, this is how we read analog input. Boleh? Ada soalan so far? Ada soalan? Okay? Yeah, I think that's all for morning session. We shall continue again after lunch, 2 p.m. Alright? Okay, if there are no questions, then I would like to dismiss the morning session. Then we shall meet again 2 p.m. Boleh? Alright guys, thank you.